Hello, I am Dr. Ritapa Bhattacharjee, Assistant Professor of Physics in Department of Basic Science and Humanities in Swami Vivekananda Institute of Science and Technology. Today, we will be solving a problem which came in the MAKAUT odd semester 24-25. So the question is, show that the gradient of a scalar function is an irrotational vector. Now, for that, let us consider a scalar function u, where u is a function which is in the Cartesian coordinate x, y, z dependent. So for that, gradient of u means I have to multiply u with the lambda operator. So operating this gradient, therefore gradient of u is equal to del x u I cap plus del y of u j cap plus del z of u k cap. Now what they asked us, show that this gradient of the scalar function is an irrotational vector. Now what is the meaning of irrotational? For irrotational vector, curl of the vector quantity has to be is equal to 0. Okay. So for a irrotational vector, the curl of the vector has to be 0. So in that case, what we are going to do, this you need not to write here. So what we will do here, we will write, I have to show the gradient of this for a irrotational vector, curl of what the question has asked us to do. It has asked us to take gradient of u. Curl of gradient of u equal to 0 if we can show, in that case our problem will solve. So for that, for a irrotational vector, this part we have to show as 0. So when we are answering it, we just write in the sentence, the curl of the vector will be equal to 0. Okay. So now what we are going to do? We are going to take the curl of the gradient. So let us take it. Therefore, curl of gradient of u will be equal to, so how we take the curl? We write it in this format. We will take the three components, I cap, j cap, k cap. So this is the curl. So curl I will be writing here, del x, del y, del z, and this component I will write the I component below of I cap, del u del x, del u del y, and del u del z. Okay. So I will just write the full form of this, and I will be doing the partial differentiation. So I will be when I am taking the I component here for the curve. So what I will do is I will multiply with del y with del u del z. I have to take this part together. So if I write here, because here is my partial derivative of y with and here the term is del u del z. So the differentiation will be my second order del 2y del y del z minus del 2u del z del y. This is my I cap component plus look here. Now I take the j component. So excluding the j column, I will use the I column and k column. So here it will be from this with this first term del 2u, twice it is getting differentiated, del 2u del z of del z del x minus this part del 2u del x del z j cap. So this is my j cap plus del 2u, this k component part, I will be taking this again, del x del x del y minus del 2u, this component I have taken, del y del x k. Now we will use a logic. What is the logic? That if you are taking derivative 2 times, the order of the derivative, how it is applied, is independent. Means, like if you are deriving u 2 times, one with respect to y and again with respect to z, then if you are taking del 2u del y del z minus, and here if you take del 2u del z del y, this order means first whether you want to write del y del z, then del 2 del z del y, this will become similar. So for that case, if you consider del 2u del y del z, I will change the order of y and z. So because it is twice differentiable, and order of how the derivative of applied will become insignificant or similar. So doesn't matter. So del y del z I have written here. So if I write del z del y, means first I am taking the derivative with respect to y, then with respect to z, and here I have taken the derivative first with respect to z, then with respect to y, this becomes equal. So if these two order of how the differentiation is taken becomes same here, in that case this whole term, this equal to this, means this minus this equal to 0. So in that case I will be writing 0 I cap plus 0 j cap plus 0 k cap, or it is 0. So what we got, therefore curl of gradient of a scalar, this is gradient of the scalar, is equal to 0. So this is my answer of the above equation. Thank you so much.